Graph the functions f of x is equal to 30 plus 5x and g of x is equal to 3 times 1.6 raised to the x on the same grid. Supply the symbol less than or greater than in the blank that would make the statement true. In order to sketch the graphs of the two functions, let's start by making a table of values. Notice in part A that we want to compare f of 0 and g of 0, so one of our input values in the table might be 0. And similarly, we might choose inputs of 6, 7, -5, and -6. Let's use the calculator to help us. Go to y equals, and for y1, enter f of x, which is 30 plus 5x. For y2, enter g of x, which is 3 times 1.6 raised to the x. To create a table, go to Table Set, which is second window. And because our inputs do not have a particular increment, we'll change the independent variable from auto to ask. Leave the dependent variable on auto so that the output is automatically given for each input. And now go to the table, second graph, and we'll enter inputs of 0, 6, 7, -5, and -6. Use the values on the table to create a table of values. Now that we've created a table, we can determine a good viewing window. Notice that the f of x values range from a low of 0 to a high of 65, and the g of x values range from a low of 0.2 to a high of 80.5. So we'll want to make sure that our y minimum is less than 0 and our y maximum is greater than 80.5. So let's first of all sketch the graphs on the calculator, and then we'll draw the graphs by hand. Go to Window, and let's go ahead and use x minimum -10, x maximum +10 with an increment of 1. For y minimum, I'm going to go ahead and stick with -10, that is less than 0. But for y maximum, I'm going to change 10 to 100, something that's more than 80. And for the y scale, I'm going to change it from 1 to 10. Go ahead and graph the two functions. We see that the first is a linear function, it graphs as a straight line. And the second is an exponential growth function. So using the calculator screen as a guideline and the table of values, go ahead and sketch the two graphs by hand. Now that we've filled in the table and sketched the graph, we're ready to complete the different parts. In part A, we want to compare f of 0 with g of 0. Looking at the table, we can see that f of 0 is 30, g of 0 is 3, so f of 0 is greater than g of 0. Looking at the graph when x is 0, we see that f, the red graph, is above the blue graph. So when red is above blue, that means that f is greater than g. Next, we want to compare f of 6 with g of 6. Well, f of 6 is 60 and g of 6 is 50.3. 60 is bigger than 50.3, so f of 6 is greater than g of 6. And if we look at x is equal to 6, we see that the graph of f is still above the graph of g. Next we compare f of 7, which is 65, to g of 7, which is 80.5. Well, this time 65 is less than 80.5, so f of 7 is less than g of 7. So this time when we look at x is equal to 7, we see that the blue graph of g is above the red graph of f. So since blue is above red, f of 7 is less than g of 7. Okay, next, f of negative 5 and g of negative 5. We see that f of negative 5 is 5, g of negative 5 is 0.3. 5 is bigger than 0.3, so f of negative 5 is greater than g of negative 5. And if we go over to negative 5 along the x-axis, we see that red is above blue. At negative 6, f of negative 6 is 0, and g of negative 6 is approximately 0.2. 0.2 is bigger than 0. 0 is less than 0.2, so f of negative 6 is less than g of negative 6. Now looking at the graph, it's kind of hard to distinguish the two. 0.2 and 0 are very close to each other. So from the graph, it's hard to tell which is greater, but using the table, it's clear. Alright, for part F, it says, as x increases without boundary, f of x compares to g of x in what way? So as x goes to positive infinity, we want to look at our graph and see what happens. As x goes out to the right, what do we observe about our two functions? Well, we notice that our red linear function f is going to be below the exponential growth function g. So we know that f of x will be less than g of x as x goes to infinity. What about as x goes to minus infinity? Well, if we look at the left-end behavior of the function, as x goes off to the left, we see that the exponential function is getting arbitrarily close to 0, whereas the linear function is decreasing down into the negative values. And the blue graph is above the red graph, or the red graph is below the blue graph. So f of x will be less than g of x.